Now we are going to start the generations of computers. So there are total 5 computer generations starting from the first, that is from 1940 to 1956. And these computers are characterized by the use of the hardware component, that is vacuum tubes. So the basic component which are used to design hardware part of these computer are vacuum tubes. So these vacuum tubes are the circuitry, that means they are the basic building block for this computer system. And these generations are using magnetic drums for memory purpose. So for circuit design, for CPU design, vacuum tubes were used, and for storage purpose, magnetic drums were used. Okay, so what is these magnetic drums and how these vacuum tubes are looking, we will see in the next coming slide the pictures of this. So the input device used was the punch cards, and output device came in the form of printouts. So here the CPU is built using vacuum tubes, storage device used is magnetic drum, input device used is punched card, and output device is printer. Okay, so as the vacuum tubes are very huge in size, they are large in size, so the huge size is there for this first generation of computers. It means they are literally taking the entire room for a single computer, because vacuum tubes are, they are using thousands of vacuum tubes, and vacuum tubes are large in size, and because of that the size of total computer is very huge, which is occupying the total room. And because there are a lot of vacuum tubes are used, so these computers are very expensive computers, and because of the thousands of vacuum tubes are used, so they are generating more electricity, they require more electricity, and they are generating more heat. So because of that there is frequent breakdowns in this first generation of computers, because heat generation is very large and they also require more electricity for consumption. So these first generation computers relied on machine language. That means a common user cannot use these computers, because these computers are using only machine language, which is in the form of 0 and 1. So only programmers could use these machines. So if any general user wants some kind of operations to be performed on this computer, so they are going to these programmers who are having these computers, they are just submitting their programs to these programmers, and these programmers will handle these computers, will make the necessary hardware changes, and then they will generate the output for their programs, and then they will hand over the output to the user. Okay, so this was a system at that time. So these computers were limited to solving one problem at a time. So these computers are not multitasking computers. These computers are able to perform only one operation at a time. So there are two famous computers of first generation, that is UNIVAC and ENIAC. These are the machines which are built in this particular time duration on the basis of vacuum tubes. Okay, so these are the features of first generation of computers. Number one, vacuum tubes are used for construction, magnetic drums for storage, punch cards for inputs, and printers for outputs. They are requiring huge size, they generate lot of heat, they consume more electricity, and they are highly expensive, and they are totally based on machine language. So these are the features of first generation of computers. In coming slide we will see the picture of this. So here we can see the first generation computer. We can see in the first diagram, these are the vacuum tubes which are very delicate. You can see they are transparent, they are made up of glass, and they are very large in size. So because of that the size of the whole computer is very large. You can see in the second diagram the size of computer is taking the whole room, and there is a programmer who are making the necessary changes in the hardware for the operation, because whenever you are doing different operation, the hardware changes have to be made manually. If addition, then hardware changes required. If multiplication, then hardware changes required. So you can see the number of vacuum tubes are there in the whole room, and the programmer is making necessary hardware changes for the operations. In the third diagram you can see the punched card in punch card machine. So punched card, you can see the machine in which the card is punched, the card is put, and the whatever numbers you want, whatever letters you want, they are getting punched on that paper. So in this way the punched card is used for input purpose. And in the fourth diagram you can see the magnetic drums. So you can see the size of the magnetic drums too. So magnetic drums, what is magnetic drum? Magnetic drum, we all know magnetic tape. So we all have seen the tape recorder, and the cassettes were used in that tape recorder. So the cassettes were using that magnetic tapes. So that magnetic tapes were mounted on this magnetic drum. So magnetic tapes is having one limitation, that they are sequential in nature. So that means we cannot go to the exact data that we want to use or that we want to play. So you all have, maybe you all have used a cassette. So in cassette we are not having facility to play the song which is exactly required. So whenever we want to play some song, we have to either forward or uh, we have to either forward or we have to either backward the whole cassette for a particular song. So this is the four diagrams which are related to first generation of computers. So your idea must be clear about the size and the devices that are used for the computer. Now the next is second generation of computers, that is from 1956 to 63, and the major component that is used for circuit design is transistor. Now the transistor size is somewhat smaller than a vacuum tube. So now we can have somewhat smaller size of computer here. And for storing purpose, now instead of magnetic drums, magnetic tapes were used. So again the size of storage device is somewhat smaller as compared to magnetic drums. So input was still punch cards and output was still printouts. Okay, so transistors were usually superior to the vacuum tubes, making computers smaller, faster, cheaper, and less heavy on electricity use compared to first generation of computers. So now second generation of computers are somewhat better than first generation in the form of size, in the form of price. They are cheaper compared to first generation, they are faster compared to first generation, they consume less electricity compared to first generation, and they generate less heat compared to first generation, because number of vacuum tubes required were more in first generation, and now we require less number of transistors, and the size of transistor is also very small compared to vacuum tubes, and because of that these are better than first generation of computers. And plus the language which is used for programming purpose was symbolic language instead of machine language or binary language. Now we are having here assembly language. So it is not in the form of 1 and 0, it is in the form of some kind of symbols, some kind of mnemonics, okay, like add, sub. So we can use here some kind of words or symbol words for expressing the instructions. So they use batch operating system. Batch operating means, as we can see in first generation, they were able to perform a single task at the same time. Here we are having the batch operating system. So programs were executed in the form of batches. For example, in a whole day, programmer will collect the programs from different users who want some kind of outputs. So at the end of the day, suppose programmers see there are 10 addition programs, 20 subtraction programs. So programmer will take all the addition programs, he will make the hardware changes and will run all the addition programs in the same way, and then he will make the next necessary changes, and then he will run all subtraction programs and will take the output. So this is called batch operating system. So these are the features of second generation of computers. So here major component for circuit design is transistor, input device is the storage device is magnetic tape, input device is punch card, output device is printout. Now they are requiring less space, they are generating less heat, they consume less electricity, they are less expensive compared to first generation of computers, and they use assembly language instead of binary language in the form of 0 and 1. So these are the features of second generation of computers. So here we can see the second generation of computers. So here in the first diagram you can see the transistors. So you can see the difference between vacuum tubes and transistor. Transistors are very small in size. So you can see the size of computer in the third diagram. So the size of computer now is very small. It is not requiring the whole room, but it is very small now. The three racks are there only in the form of these transistors. And you can see here the magnetic tape storage device. So magnetic tapes are also small in size compared to magnetic drums. Okay, so this is the second generation of computers. Now the next is third generation of computers, which is from 1964 to 1971, and now the component for circuit design is ICs, integrated circuits, which are very small in size compared to transistor. One IC can comprise of thousands of transistors in it. Okay, so by this phase, transistor were now mounted on silicon chips, that is semiconductors, or they are called as ICs. So now number of transistors can be mounted on a single IC. So now you can imagine the size of computer. Okay, so this led to a massive increase in speed and efficiency of these machines. Okay, now speed is very fast compared to second generation of computers, and these were the first computers where users interacted using keyboards and monitors which interfaced with an operating system. So now these are the computers we can see which normal user can operate, because now these computers are using operating system. These computers are using keyboard as an input device and monitor as an output device. So these are the computers which can be used by general users also. So as a result of these advances, these which again made machines cheaper and smaller and large in storage capacity. So these are small in size, less expensive, and they can able to store large number of data. So you can see in this diagram, the first diagram, the other ICs, integrated circuit. So instead of using thousands of transistors, we can use a single IC. So you can see the size of computer is getting very small now. So this is the computer which was used in computer labs, even at home, by the general users. And now the input device is keyboard and output device is monitor. So this is the motherboard of the computer. So we can see the different kinds of ICs are mounted on this motherboard. So this is the advanced or you can say this is a massive innovation in the generations of computers, because now the programmers are not required for program. The normal user can also operate the computers by themselves for their own purpose. The next generation is the fourth generation, that is from 1972 to 2010. So now this revolution can be summed in one word, that is Intel. So here the Intel brand has made the evolution in the generation of computers by developing the Intel 4004 chip in 1971, which positioned all computer components, that is CPU, memory, input output controls, on a single chip called microprocessor. So fourth generation of computer is mainly characterized by the evolution of microprocessor. So microprocessor is a chip that is comprising of all the components inside, that is CPU also, memory devices also, that is RAM, ROM, and they're also having their input output controls. Okay, so the Intel chip housed thousands of ICs. As we have seen in third generation, ICs were used. So here now a single microprocessor can have thousands of ICs. So one IC were having thousands of transistors mounted, and now one microprocessor can have thousands of ICs mounted. So now you can imagine the size again. So now size is becoming very small. So this technology is called VLSI technology, that is very large scale integration, because now thousands of ICs are mounted on a single chip, that is microprocessor. Okay, so now these computers are using graphical user interface, the mouse, and more recently the advances in laptop capability and handheld devices. So here we can say the smartphones is example of fourth generation of computer. Laptop is an example of fourth generation of computer. So these are providing graphical user interface. So we can see the icons, we can see the symbols, we can see the pictures, and we can use a mouse as a pointing device, we can use a touch screen as a pointing devices. So they could be linked creating networks. So here we can use these computers with internet connectivity also, we can use these computers over network also, and which ultimately led to the development, birth and rapid evolution of internet. So here these computers can be used for internet purpose also. So by coming to fourth generation, computer became very small in size and becomes portable. We can transfer one computer from one place to another place easily. So they are very small in size that we can transfer them from one place to another place. That's why they are called as portable devices. So they generate very less amount of heat, they are much faster and much accurate compared to other generations. So the production cost reduced to very low in comparison to previous generations. So they become available for common people as well. So microprocessor can also be used in an increasing number of everyday products. So microprocessors are not only used in computers, but they are used in many household devices also, like they are used in television remote controls, they are used in microwaves, they are used in washing machine. So these are the processors which are used in some household devices also. Okay, so this fourth generation is a massive advancement in generation of computers, because now we are having very small size devices which we can transfer from one place to another place. They are very cheap and they are having less power consumption, less generation of heat, and most importantly they can be connected to network and we can use internet on these devices. So here you can see the diagram. The number first figure is the microprocessor, which is having lots of ICs inside, and you can see now the size of computer devices, that is very small in size. We can easily port from one place to another place. So these are the microprocessor chips, and there is a circuit board on which the microprocessor is mounted and different ICs are mounted. So the size now is very small and easy to use. So the last generation is the fifth generation of computers, that is from 2010 onwards, and this generation is characterized by the use of artificial intelligence. So up till now we have seen four generation, first to fourth, and all are based on the different innovations in hardware technology, that is vacuum tubes and transistors and IC and then microprocessor. Okay, so these generations were characterized by the use of hardware component for the circuit design, but the fifth generation of computer is totally characterized on the basis of software innovation in the field of computers. So the period 2010 to till date and beyond roughly considered as a period of fifth generation of computers. So by the time as we already discussed, the computers were characterized by the use of hardware, but this generation is characterized by the use of software technology. So the computers of fifth generation had high capability and large memory capacity, and working with these computers is very fast and multiple tasks could be performed simultaneously. So these computers are multitasking computers. They can able to perform a lot of tasks at the same time, and they are very fast in speed and they are large in capacity. Some popular technologies that are used in fifth generation of computers are artificial intelligence, parallel processing, etc. So parallel processing means a single computer now can have multiple CPUs, multiple processors for processing the instructions. So you can imagine the speed. Now if you are having 10 processes, 10 tasks, so if you are having two CPUs inside, two processors, so five process are divided into two CPUs. So you can imagine the speed now. So these are the parallel processing computers. And artificial intelligence. Now what is artificial intelligence? Just you can imagine the example of washing machine here. So the tasks which are performed by the human beings are performed by the computers now, the machines now. So this is called artificial intelligence. So human being is able to wash the clothes, and the same intelligence is inbuilt in a device, and that technology is called as artificial intelligence. Okay, now you can take the example of microwave. So human being is able to cook the food. We are having intelligence of cooking the food, and that same intelligence is artificially inserted into the machine using the fifth generation technology. So that is called artificial intelligence. So these all devices are the examples of artificial intelligence. And robotics is also one of the example of artificial intelligence. What we can do, the robot can also do, because but they are not having intelligence, it is inbuilt in them by using their softwares. Okay, so this is called artificial intelligence technology, and this is an example of fifth generation of computers. So here you can see the examples of fifth generation of computers. Here robots are there. So these robots are playing the game with the human being. So here we can see the another example in this third diagram, that is a menu card. So there is no manual menu card here. On the table itself you can able to see the menu, and you can just go to the menu, and you can just use that table as a touch screen only. So this is called this is called the fifth generation technology. So here we have completed the five generations of computers.